Welcome to Voice Bootcamp, a global name in unified communication. Hi, my name is Faisal Khan, Cisco Voice Instructor at Voice Bootcamp. In this particular chapter, we will focus on PSTN and gateway devices in UCCE infrastructure. If you take a look at the UCCE architecture, you will see that there are many different components working together to provide a complete solution to a customer. One of the most important devices or component is the voice gateway, which is used to receive and send calls from a service provider to an enterprise. Here's an example of a voice gateway receiving call from a service provider or PSTN and sending calls to internal network. This particular voice gateway is considered to be either egress or ingress gateway. Or they are connected to a service provider using a TDM connectivity such as T1, E1, or in the latest technology, most companies are starting to moving into SIP trunking. As SIP trunking is becoming very popular, the use of latest technology is becoming more and more common. Now, when you use a SIP trunking, the gateway should have a special feature from Cisco called Cube, or Cisco Unified Border Element. Now we'll talk about Cube a little bit later. So in this scenario, the voice gateway is receiving call from a service provider, PSTN, sending the calls to a call manager using some sort of protocol. Now, one of the most important part here is the voice gateway must use a common signaling protocol to talk to service provider, which is in this case the PSTN. Once the voice gateway receives a call from a service provider, then it has to use a different protocol such as H323, MGCP, or SIP to communicate with the call manager. So we will talk about some of this protocol briefly in the later in the topic. But if you have taken the CIPT course or CCNP Voice IP Telephony Part 1, these topics are covered more in details. So what is a PSTN gateway? Well, the PSTN gateway's primary role is to send and receive calls from a carrier and to the network enterprise, and vice versa. So a PSTN gateway is responsible for delivering calls inbound to a voice gateway. An inbound call is received with a specific information known as DNIS, or Dialed Number Identification Service. This particular number is basically the number that user from the outside world actually dialed to reach somebody in the inside, which is enterprise, or vice versa. So basically the number that you actually dial is known as DNIS. This number will basically instruct the gateway what to do with the call. Now, DNS may be used by UCCE to disclose the caller's intent and objective. For example, sales or support. Well, if you call, let's say you pick up a phone and you call Microsoft to complain about a product. So you pick up their phone number, which is basically, let's say, customer service. So most likely, if complaint department, they have a separate number. When you dial that number, Microsoft contact center server will realize that that number is for the complaint department. Well, so the contact center already made the decision that this call is about making a complaint. So the intent of the caller was actually disclosed. The DNIs may vary in length. Now, it all depends on service provider. When a service provider provides you T1 or E1 line, or even SIP trunk, provisional SIP trunk, they will always ask you in advance how many digits do you want me to forward it to you. So in other words, if somebody dialed 11-digit number, me as a service provider, how many digits should I send to you? Should I send all 11-digit? Should I send you 7-digit or 4-digit? So the DNIs may vary. Of course, that is dependent on your business policy. In this example, the PSTN will deliver the call with a 4-digit DNIS. Voice gateway or Cisco CM will modify the digit to present to the downstream devices such as the phone itself. Now, gateways, like I said, plays a greater role in Cisco contact center environment. Once the gateway establishes a call through the call manager, the RTP will be between the gateway and the end device itself. But this particular call from the ingress gateway can reach the endpoint multiple ways. For example, a call can come from the gateway to the call manager to the phone. Or you can use SIP proxy servers to send the calls to the proxy, which will send to the call manager, then to the phone. Or the call can go through the gatekeeper to the call manager and then to the phone directly. So these are the different ways of routing calls in your Cisco contact center environment. Use Cisco SIP proxy for high volume calls, scalability. You can use SIP proxy for redundancy purpose or centralized management. Gatekeeper, same purpose. You can use gatekeeper as a centralized management dial plan to send calls to final destination. Now, if you take a look at this environment, in the step number 1, we have received a call from service provider, from a user in a public world, such as the caller will dial 408-201-2001. This call will arrive into my call manager using the ISDN signaling or PSTN signaling. Now the gateway has to make a decision what to do with this call. So what the gateway does, well, if you're going to go to call manager directly, gateway has to choose one of these 3 protocols: HTTP, MGCP, or SIP. So if you're going to use SIP direct, you can send the calls from a Cisco router directly to a voice gateway, or sorry, call manager in this scenario. So the call is arriving to call manager. In this scenario, the gateway, ingress gateway, will be able to choose only one of these protocols to send this particular call to call manager. Now, because it's choosing only one protocol doesn't mean the router cannot run multiple protocol. It still can run MGCP or SIP simultaneously, but at any given time the router will only select one protocol for a particular destination number. So if you take a look at another scenario where the call is actually going through a SIP proxy server as opposed to call manager. So the step is the ingress gateway will then first send the calls to the proxy. Proxy does its own job and send the calls to the call manager, and then call manager will ultimately send the calls to the destination. Gatekeeper concept pretty much the same. In step number 2, the call will go to the gatekeeper, which will ultimately send the calls to call manager and then to the final destination. So as you can see, the multiple ways of routing calls between the ingress gateway to the final destination. Now, from the call manager to the phone, it could be either SIP or skinny traffic or SSCP. Now, regardless of which protocol the call is going through, when the call is actually finally gets connected, the communication will be between the gateway and the phone itself directly. Now that's the RTP channel. The old school method, we use PRI trunk or to traditional PSTN provider. The new school method would be to use SIP trunk to your service provider. In order to use SIP trunk, it is recommended that you use Cisco Unified Border Element to provide inter-networking between these two VoIP networks. Now, whenever you use SIP trunk, always keep in mind you are now dealing with a service provider's network, so therefore which you do not have a control over. So therefore, quality of service will be an issue. So you may have to take extra precaution steps to ensure that QoS is met according to your business policies. Now, one of the advantages of Cube compared to other protocol is that on one side you can use MGCP, SIP, or HTTP3. On the other side, you can use totally different protocol. You can use G711 codec in one side, G729 codec on the other side. The Cube has the capability to do the translations. Now, the Cube itself has many different features: session management, internet working, demarcations, and security. Session management, for example, real-time session management. It can provide call admission control. It can provide gateway fallback, statistic and billing, redundancy and scalability. These are built onto your Cube sessions. Interworking is, for example, like I said, one side could be H.323, other side could be SIP. It does support DTMF, internet working, transcoding, codec filtering, and so and so. Demarcation, basically topology hiding. You can hide internal network from outside. You can route every call through the proxy server so that the direct communication is no longer between the gateway and the phone, but between the phone and the proxy, and the gateway and the proxy. And then for security perspective, you can enable encryption, authentication. You can require the SIP gateway to register. You can use firewall replacement, toll fraud. All these features can be built in to Cube solution. So the benefit of Cube is obviously is exceptional scalability, extensive support for digital signal processor, box-to-box or inbox redundancy is built in. Cube, however, does not support a few occurrence of UCCE deployment. For example, if you are going to use this UCCE outbound option, which does not support SIP over Cube. Mobile agent does not support SIP over Cube. Cube over SIP-tron. So whenever you're designing voice gateways, always consider various aspects. For example, you want to make sure that that the gateway you select is, will be able to handle the number of calls that you have. Gateway can support the protocol that you're about to select, whether it's an H323 or SIP. Let's assume if you buy a third-party gateway that is acting as an MGCP. Well, third-party MGCP gateway may not work with call manager, for example. Provider type, whether the call gateway is going to be going to interconnect with TDM network or SIP trunk provider. So obviously, if it is a TDM network, then you need to purchase the necessary devices. If you are going to use SIP only, then you need to make sure that you have the proper licensing for UCCE, Cube features. Inbound and outbound agent. If you're going to use outbound agent, you have to make sure the SIP protocol doesn't work with outbound agent over Cube. Mobile agent, same concept. Transcoding and mid-call negotiations requirement, especially when an agent is talking to a customer. Imagine the agent all of a sudden say, "Okay, please stay on the line. I'm going to get my manager involved into this call." Well, if the agent in conference a manager into a particular call, that call requirement is now changed, right? Because initially it was between point to point, between two person. Now you have three persons. So you need to change that session into a little bit larger bandwidth so that it can support a conference. In this scenario, DSP and MTP resource will be required because your gateway will connect to WAN or some sort of LAN. Make sure you have QoS and bandwidth check. Gateway should be able to provide failover and high availability requirement in order to ensure that if in case the gateway fails, there is an alternative way to route the call.